Let me begin with a deceptively simple question, the kind of question a child might ask, and the kind that would immediately capture the attention of Richard Feynman. If the universe is full of stars, why is the night sky dark? Now don't rush past that. Slow down, think about it carefully. When you step outside at night, you see points of light scattered across a vast black background. It feels sparse, quiet, almost empty. But we know something extraordinary. Our galaxy alone contains hundreds of billions of stars. And beyond our galaxy, there are hundreds of billions of galaxies. In every direction you look, space stretches outward with unimaginable abundance. So here's the logic, and it's simple, almost uncomfortable in its simplicity. If the universe were infinite, and if it had been around forever, then in every direction your line of sight should eventually hit the surface of a star. Maybe not a nearby one, maybe not one in our galaxy, but somewhere along that infinitely long line there should be a glowing sun. And if that were true, the entire sky should blaze with light. The night sky should not be dark. It should be as bright as the surface of the sun. This puzzle is known as Olbers Paradox, but calling it a paradox almost hides its power. It's not just a physics problem. It's a crack in our assumptions about reality, because what this question does, brilliantly, is expose the danger of careless thinking about infinity. We say words like infinite, very casually, infinite space, infinite stars, infinite time, but infinity is not poetic. It's not mystical. It has consequences, logical consequences. If space is infinite and eternal, then darkness becomes impossible. Now, some people once tried to solve this by saying, well, maybe dust blocks the light. That sounds reasonable. But think a little deeper. Dust absorbs light. And if the universe has been around forever, that dust would heat up. Eventually, it would glow just as brightly as the stars themselves, so that explanation collapses. You see what's happening here. A simple observation that the sky is dark forces us into a confrontation with our assumptions. It forces us to ask which of our beliefs about the universe are wrong. This is where the intellectual discipline of Feynman becomes powerful. He would insist on something very uncomfortable. Don't explain the mystery away. Sit with it, let it disturb you, because the darkness is not trivial. It is evidence. Every time you look at the night sky, you are looking at a contradiction between expectation and reality. If the universe were static, eternal, and infinite in the naive sense, the sky would be ablaze, but it isn't. And here's where the psychological dimension becomes interesting. Human beings are uncomfortable with emptiness. We prefer fullness. We prefer completeness. An infinite universe filled uniformly with stars feels grand, stable, almost reassuring. But the dark sky whispers something else. It whispers that the universe is not static, not finished, not timeless. It suggests limitation, and limitation is unsettling, because if there is a limit to how far light has traveled, then there is a limit to time itself. If there is darkness between stars, then perhaps the universe has not existed forever. Perhaps it has a history. And suddenly, the night sky is no longer a backdrop. It is a record, a boundary, a message. What fascinates me is that this entire philosophical earthquake begins with a childlike question. Why is it dark? That's the genius of approaching science the way Feynman did, not with arrogance, but with curiosity sharpened by logic. He would say, in essence, don't be impressed by big words, follow the reasoning. And the reasoning leads us somewhere profound. The darkness is not an absence of stars. It is a clue about the nature of reality. Think about that the next time you stand under the night sky. The blackness above you is not emptiness. It is structure. It is information. It is the signature of a universe that has not had infinite time to flood itself with light. The paradox forces us to abandon comfortable myths about eternity, and confront a dynamic cosmos instead. And here is the deeper lesson, not just about astronomy, but about thinking itself. When reality contradicts your expectations, do not deny reality. Question your expectations. The dark sky is not a failure of the stars. It is proof that our assumptions must evolve. So if the dark sky forces us to question the idea of an eternal, unchanging universe, then we are led to a far more radical conclusion, one that reshaped modern cosmology. The universe has not been here forever. That statement alone overturns centuries of assumption. For a long time, even brilliant minds like Isaac Newton imagined a static, infinite cosmos. Stars scattered endlessly through space, existing without beginning or end. It felt philosophically comfortable. No origin, no boundary, just permanence. But the darkness above us refuses to cooperate with that picture. If the universe had existed for an infinite amount of time, then even the most distant stars would have had enough time for their light to reach us. Every corner of space would have illuminated every other corner. The sky would glow uniformly, yet it doesn't. And that means something extraordinary. Light has not had infinite time to travel, which means time itself has not been infinite. This is where the implications of the Big Bang become unavoidable. Not as a dramatic explosion in space, that's a misleading image, but as the beginning of space and time themselves. Roughly 8 billion years ago, the universe was in a hot, dense state and has been expanding ever since. Now pause and feel the philosophical weight of that. Time had a beginning, there was no before, in the ordinary sense. Asking what happened before the beginning of time is like asking what's north of the North Pole. The question collapses under its own misunderstanding. The darkness of the night sky becomes evidence of this beginning. When we look outward, we are also looking backward. Light travels at a finite speed. When you see a star 1,000 light years away, you are seeing it as it was 1,000 years ago. When you observe a galaxy billions of light years away, you are witnessing ancient history. There is a limit to how far we can see, not because our telescopes are weak, but because the universe itself has a finite age. Beyond a certain distance, there simply hasn't been enough time for light to reach us. That boundary is called the observable universe. And psychologically, that's humbling. We like to imagine that reality is fully accessible, that with better tools we can eventually see everything. But the darkness reminds us that some regions of the cosmos are fundamentally unreachable, not hidden by technology, but by time itself. This changes how we think about existence. The universe is not a static stage where events unfold endlessly. It is a process. It has a narrative arc, a beginning, an evolution, structure forming over billions of years, stars igniting, galaxies assembling, planets cooling, life emerging. And we are latecomers in that story. What I find deeply moving, and what someone like Richard Feynman would appreciate, is that this profound conclusion does not come from mystical speculation. It comes from careful reasoning tied to simple observation. The sky is dark, therefore the universe cannot be infinitely old in the naive sense. It's an example of how disciplined curiosity can lead to revolutionary insight, but there's also a psychological mirror here. Many of us live as if our own lives are static, as if the way things are now is the way they have always been, or always will be. We forget that we too exist within time's arrow. We are part of an unfolding process. The universe began. It changed, it evolved complexity from simplicity. Out of hot plasma came stars, out of stars came heavy elements. Out of those elements came planets. Out of those planets came consciousness capable of asking why the sky is dark. You are not separate from that history, you are a continuation of it. The darkness above you is not empty, it is unfinished time. And here's the deeper philosophical shift. If the universe has a beginning, then reality is not fixed. It is dynamic, it moves, it transforms, it generates novelty that should change the way you think about possibility. Because if the cosmos itself is an evolving system, then stagnation is not the natural state of things. Growth is, change is, emergence is. The night sky becomes a reminder that everything you see and everything you are exists within a finite, unfolding timeline. And that finiteness gives meaning, it gives urgency. We are not floating in an eternal, unchanging void. We are living in a universe with a history and therefore with direction. The darkness is not just evidence of a beginning. It is proof that time matters. Now, even after accepting that the universe had a beginning, we are still left with something even more subtle and in many ways more astonishing. The universe is not just finite in age, it is expanding. This discovery, first clearly articulated through the observations of Edwin Hubble, changed everything. When astronomers looked at distant galaxies, they noticed something peculiar. The light coming from them was shifted toward the red end of the spectrum. Not randomly, systematically, the farther away a galaxy was, the more its light was redshifted. That wasn't just a technical detail. It was a clue. Redshift means stretching, and stretching means motion, not motion through space in the ordinary sense, but space itself expanding. Galaxies are not flying outward into emptiness. The fabric of space between them is growing. Now think about what that does to light. Light travels in waves, and if space itself stretches while light is moving through it, those waves stretch too. Their wavelength increases, their energy decreases. Visible light can shift into infrared. Infrared can shift into microwave. Eventually, some radiation becomes so stretched that it is completely invisible to the human eye. So when you look up at the night sky and see darkness, it does not mean there is no light coming from those distant regions. It may simply mean that the light has been stretched beyond your ability to perceive it. Darkness, then, is not the absence of light. It is light transformed. This is a profoundly different way of thinking. We tend to trust our senses. If we don't see something, we assume it isn't there. But the expanding universe quietly undermines that assumption. Much of the radiation filling space is invisible to us, shifted into wavelengths our eyes cannot detect. The sky is not empty. It is saturated with signals we cannot directly perceive. This should make us intellectually humble. Someone like Richard Feynman would insist on this humility. He often emphasized that nature is under no obligation to make itself obvious to human intuition. Our brains evolved to survive on a small planet, not to comprehend cosmic expansion. So when reality behaves in ways that feel counterintuitive, the problem is not reality. It is our expectations. The expansion of the universe teaches us that perception is not the same as truth. You see blackness, but beyond that blackness, ancient galaxies are pouring out light that has been traveling for billions of years. By the time it reaches us, it has been stretched, diluted, cooled. It whispers rather than shines. In fact, we have detected this faint afterglow, the cosmic microwave background, the cooled remnant of the early universe. It fills all of space, almost uniformly. The universe is not dark in an absolute sense. It glows softly in microwave radiation, invisible to our eyes but unmistakable to sensitive instruments. Psychologically, this is powerful. How often in life do we interpret silence as absence? How often do we mistake invisibility for non-existence? The expanding universe reminds us that reality operates on scales and frequencies beyond immediate perception. Darkness is sometimes just transformation beyond our current sensitivity, and there's another layer here. As space expands, Distant galaxies move away from us faster and faster. Some are already receding so rapidly that their light will never reach us. Not because it isn't being emitted, but because space is expanding too quickly for the light to close the gap. There are regions of the universe permanently beyond our observational horizon. That realization is both awe-inspiring and unsettling. There are events happening right now that we will never see, not because we lack intelligence, not because we lack technology, but because the structure of space-time itself prevents it. This changes the way we think about knowledge. We often imagine that with enough progress, enough science, enough persistence, everything will eventually be known. But cosmic expansion sets limits. There are boundaries to observation built into the geometry of reality. And yet, within those limits, we have discovered extraordinary truths. We figured out that the universe expands. We measured the redshift. We detected ancient radiation. We inferred a beginning, all from a dark sky. That's the deeper lesson. The night sky is not just a backdrop for romance or poetry. It is an active participant in revealing the structure of space-time. Its darkness encodes information about expansion, energy, and the limits of perception. So the next time you look up and see blackness between the stars, don't interpret it as emptiness. Interpret it as motion, as stretching, as transformation. The universe is not silent. It is speaking in wavelengths beyond your eyes. And the real question is not why it is dark. The real question is whether you are willing to look beyond what you can immediately see. So now we've walked through the logic. The sky is dark, which means the universe cannot be infinitely old in the naive sense. The universe had a beginning. It has been expanding. Light is stretched, diluted, shifted beyond what our eyes can see. But here's the deeper question, the one that someone like Richard Feynman would really care about. What does this teach us about how to think? Because the scientific facts are extraordinary, yes, but the method, the mindset, is even more powerful. The darkness of the night sky is not just a cosmological detail. It is a lesson in intellectual humility. It reminds us that the universe does not conform to our intuitions. For centuries, humans assumed the cosmos was eternal and unchanging because that felt stable. It felt complete, but a simple observation, blackness between the stars, quietly dismantled that assumption. And that's the pattern of real discovery. Reality whispers contradictions. Most people ignore them. A few lean in. Feynman often spoke about the importance of not fooling yourself, and the easiest person to fool, he said, is yourself. When we look at the night sky, it's easy to romanticize it, to project meaning onto it, but the scientific approach demands something more disciplined. It asks, what must be true if this observation is accurate? The sky is dark. Therefore, something about our prior assumptions must be incomplete. That willingness to question foundational beliefs, that's the real engine of progress, not certainty, not authority, not tradition, curiosity disciplined by logic. And here's where the philosophical depth emerges. The darkness tells us the universe evolves. It changes. It had a beginning. It stretches. It transforms energy across time. In other words, reality is dynamic, not static. And yet, psychologically, we resist that idea. We crave permanence. We want things to stay the same. We want certainty about the structure of the world, about our place in it. But the cosmos offers no such comfort. It offers process. It offers motion. It offers emergence. You are living inside something unfinished. Think about that. The stars you see are not eternal fixtures. They are born, they burn, they die. Galaxies collide. Space expands. Even the observable universe has limits defined by time and geometry. Nothing about this picture is static. And that realization should do two things at once: humble you and empower you. It humbles you because it reveals how small your immediate perspective is. Your eyes capture a thin slice of the electromagnetic spectrum. Your lifetime spans a blink of cosmic history. Your intuitions evolved for survival, not for understanding space-time. But it empowers you because, despite those limitations, you can understand. You can infer. You can reason beyond your senses. You can uncover truths about billions of years of cosmic evolution from the simple fact that the sky is dark. That is extraordinary. The night sky is not empty. It is layered with information. It encodes the age of the universe, the expansion of space, the limits of observation. It is a canvas painted with physical law, and here is the part that should motivate you. If such profound conclusions can arise from questioning something as ordinary as darkness, what else in your life have you accepted without examination? What assumptions are you living under that feel obvious, natural, unquestionable, but might collapse under careful reasoning? The method that unlocked the structure of the universe is available to you. Observe carefully, question deeply. Follow the logic wherever it leads, even if it disrupts your comfort. Feynman's brilliance was not just in solving equations. It was in protecting his curiosity from complacency. He never allowed familiarity to dull his sense of wonder. He treated simple questions as doorways to profound insight. Why is the sky dark? Behind that question lies the age of the universe, the expansion of space, and the limits of perception. Behind your own simple questions may lie transformations just as significant. The darkness above you is not a void. It is an invitation to think rigorously, to doubt constructively, to embrace uncertainty as the beginning of understanding rather than the end of it. The universe is not silent, it is subtle, and if you learn to listen carefully not just to the stars, but to the contradictions in your own thinking, you will discover something powerful. The greatest breakthroughs begin where comfort ends.